Greetings everyone. Good morning, good afternoon, good evening from wherever you are joining. Very warm welcome to the Kubernetes Chaos Engineering Meetup. I'll be your host, Prithvi from the Litmus community, the Litmus community manager. And we'll be talking about Kubernetes Chaos Engineering in brief, as well as we'll be talking about various aspects of Litmus which make your Kubernetes Chaos Engineering or cloud native chaos engineering journey very easy while you move ahead. We have a stacked agenda today. I'll be moving on to the agenda. But before that, please feel free to ask any questions that you have on chat. We'll be answering them one by one. And secondly, if you want to raise anything, or if you want to introduce yourself, if you want to ask anything specific, then you can raise your hand and you can unmute and ask your question as well. And we'll be forwarding the links as per necessary in the chat itself. So make sure you follow them. So moving on to the agenda, as we have in store, there's a stacked agenda that we have, and there are a lot of things perhaps that you might be interested in. So let's get started with the agenda. The agenda items as we have is, first, we'll be introducing chaos engineering. As we see, there are a lot of new folks who are joining in, a lot of new folks who are taking interest in the idea of chaos engineering. So we'll just introduce chaos engineering briefly in a very short span of time. And then we'll move on to the various in-depth aspects of chaos engineering or Litmus chaos, or how you can curate your first chaos experiment and then go in depth into it. So target identification in Litmus Portal by Amit. He'll be explaining the portal and how you can curate your chaos workflows and identify targets. And then you'll be learning about improving chaos engineering analytics by Ishan, Gupta and Ritik Srivastava. They both have been amazing Litmus contributors working on the analytics section. And lastly, we'll have Udit Gaurav, who will be explaining the DNS chaos experiment, and he'll be running through a quick demo for you all. So without wasting any time, I'll be starting off with the agenda item that's first in hand, that is introducing chaos engineering and introducing to you what exactly Litmus Chaos is, and then we'll move ahead. So as you can see, reliability for hybrid clouds, cloud native chaos engineering, obviously introduction to Litmus Chaos. So our agenda items will host what is chaos engineering, what is cloud native chaos engineering, and a short overview of Litmus Chaos. Chaos engineering, as you know, obviously a term which was coined by Netflix back in 2011-12, and it was all about reliability. It was all about system resiliency. And why were they concerned about system resiliency? Because downtimes are expensive, outages are very expensive. They lead to a certain stage where there's no coming back. So why not test your system beforehand? Why go to these outages or these downtimes, which can cause a huge loss? I mean, you can take an example of a big billion day sale curated by Amazon, or curated by Flipkart, or a great Indian festival that happens as an Amazon sale. What happens where there's a spike of users? There's an outage, or there's a possibility of an outage. So that is where chaos engineering comes into play. We need to understand that feedback loop can be activated by proactive testing in production. It's very important for us to test, not just in production. As you can see, the DevOps loop gets activated, not just in production, but it's also very important for each and every one to test in staging, in the CI/CD pipelines, in the developer clusters. There are various stages where you can test, where you can use chaos test, and obviously adopt the chaos first principle. So what has been the state of chaos engineering till now? Obviously, standard practices do exist. They are limited to experts and enthusiasts, but it's also important for us to understand that it's not just about the standard practices, or it's not just about limiting it to a certain section of people or large deployments. Even a smaller section of people or smaller deployments can help you. Even a single chaos test or a chaos workflow can help you to get started with chaos engineering, because as of now, for those who have burned their hands, they have seen a resolution being chaos engineering. But it's important for each and every developer or each and every enterprise to start the adoption journey. Moving on, how it is done typically, there are various ways how it is done. Typically, game days, they are sometimes integrated to the CI/CD, or as of now, mostly SREs are focusing upon chaos engineering, but the developer environment or the developers are not going ahead to focus on chaos engineering. And it needs a lot of planning and execution. That's what the belief is, but that's not the truth. You can just start off by running a chaos test if you do it in a controlled manner. Chaos observability, as we talk about observability, monitoring, and logs and events, it's not a commodity. It's a custom built stack at each enterprise as of now, but it can be changed with the scenarios of various tool sets and various projects coming in, and especially from the open source world. We'll talk about that later on. So that is how it is done typically, but I wouldn't completely agree with it, because there are various aspects that change the chaos engineering journey. So benefits of chaos engineering, obviously you need to understand what's the benefit to obviously start off with chaos, right? So you can run services obviously without an outage. Preventing an outage, as we focus on chaos first principles, why not conduct a chaos engineering experiment beforehand? Why to wait for an outage? And obviously there are certain business SLAs and SLOs, service level agreements and service level objectives, that need to be fulfilled. There was a recent SLO conf that was hosted, which just focused on SLOs. So chaos engineering and SLOs, I believe, go hand in hand. They help each enterprise or each developer meet certain amount of SLOs. And then obviously chaos engineering helps your system, microservices systems and architectures are scalable already, and they help your services to be scaled on your demand. You can always scale your chaos experiments or understand the system requirements and act accordingly. And then you can slowly go ahead upgrading your services without an outage, the way you conduct your chaos engineering use cases or your POCs, and slowly you upgrade your services. So obviously chaos engineering is trending in tech. There are a lot of tool sets. I think CNCF has clearly mentioned that chaos engineering is one of the top 5 technologies to watch in 2015. And there are a lot of projects which are coming in. There's Chaos IQ, I mean, that's Chaos Toolkit, then Mesh, Chaos Mesh, Powerful Seal, Chaos Blade, Cube Invader, Cube, even SteadyBit on the enterprise side, SteadyBit or Gremlin. And then AWS has announced their FIS, but we'll be focusing on Litmus as Litmus community organizes this, but these are the other projects that are part of this trending technology. So reliability obviously is a budding challenge. There are a lot of trends that are being followed in the containerized world, but as you can see, reliability is as a challenge, it's almost 12% of the whole community faces this challenge, and complexity again 41%. So these few aspects are what these container challenges are, all that help us understand the value of chaos engineering, why chaos engineering is important, and why is it important for the DevOps space. GitOps is growing significantly. Chaos engineering practices, there's a rise in AI ops, FinOps, and these practices. So chaos engineering can be worked out with all these DevOps practices, or as a DevOps practice, chaos engineering is a must, not just for SREs, but for the whole ecosystem. Perhaps, yeah. So Kubernetes needs a resilient tool set. What we focused on Kubernetes, but it's all about the overall cloud native environment, because traditional chaos engineering tools, they do not suit for Kubernetes, because obviously they are not cloud native. We'll understand what cloud native chaos engineering is, but according to the SIGAP delivery in the CNCF, it's very important for us to focus on operators, GitOps, and chaos engineering. And what are the driving factors? Continuous verification, SLOs, as I said, and chaos engineering in various platforms, because every day some or the other outage is happening, and it's not about understanding when does that outage happen. It's about preventing that outage before that outage happens usually. So moving on, cloud native chaos engineering. What exactly cloud native chaos engineering is, and what are the principles that we believe about cloud native chaos engineering. So according to us, these are a few basic principles of cloud native chaos engineering. A tool set should be open source. That is obviously, hosting it on GitHub, and most of the tool sets today are being open source. The open source world is transitioning. Community interaction is very important. Different enterprises or different users have different use cases, and these use cases help a community build the project, help to understand how chaos engineering can be developed. Open API and lifecycle management, obviously there should be an open API so that people can bring their own chaos take the chaos engineering experiments and use it on various cloud providers. And obviously scalability is what we were talking about. And through GitOps in chaos engineering, we have started to focus on making chaos engineering more scalable and more appropriate, as there's a shift to the GitOps world. There's also a GitOps day or conference happening soon. So open observability, we always want to focus upon monitoring logs and events which can be used or which can be seen through Prometheus or Grafana. So they are built on the foundation. And now we'll move on to how we have followed these principles. Litmus Chaos as a project, as a tool set, follows all these aspects, all these features. It completes all the features that cloud native chaos engineering should have. And we have tried as a project to bring all of them, but in case you feel there are any other aspects of cloud native chaos engineering, feel free to let us know in chat that this can also be a feature for cloud native chaos engineering or curating chaos testing in a cloud native way. So just starting off with an overview of Litmus Chaos. Litmus obviously is an open source tool set for practicing highly scalable chaos engineering practices, or is a chaos engineering framework which helps SREs, developers, or anyone from this ecosystem to practice chaos tests. And there are 54 plus chaos experiments, I think, from generic to AWS related. And even I can tell you there's a new VM chaos experiment that is out there. And these are a few stats. It's an open source project, so anyone can come out and contribute. Anyone can come out and give community feedback. And we have a Slack with Slack community where you can join in and you can talk about what exactly chaos engineering is, or what according to you can be changes in terms of using chaos engineering at your enterprise or with your infrastructure. So just talking about how Litmus is deployed. Litmus is usually deployed on the control plane as a Kubernetes cluster, but it's not just meant for Kubernetes workloads. It's also meant for non-Kubernetes workloads as well. And there's a portal which acts as a UI where you can visualize everything. You can visualize your workflows, you can visualize and monitor them, and you can curate them easily. And obviously there's a chaos operator and a workflow controller which controls the chaos engineering workflows, and the operator pulls a chaos experiment from the Chaos Hub. Chaos Hub is basically a marketplace. I'll just take you through the Chaos Hub, what exactly it is and what experiments it hosts. And then obviously there's also non-Kubernetes chaos experiment CRD, a custom resource, which helps you access an API through which you can also curate experiments in your cloud providers such as AWS, Google Cloud, Microsoft Azure, VMware, through an experiment pod. So it's not just meant for Kubernetes deployments, although it's a Kubernetes Chaos Engineering Meetup, we talk about it, but it's also meant for non-Kubernetes Chaos Engineering deployments. You can curate chaos in your AWS, GCP, Azure, and VMware. So moving on, I'll just give you a sneak peek of the Chaos Hub, and perhaps post that we can have Amit Das talking about the portal and how you can curate chaos experiments. So as you can see, this is the Chaos Hub. I'll send out the link. Here there are various experiments. As of now, you can just check the master section. There are 54 experiments, and there are various experiments, generic experiments, Kafka based experiments. There's a project called OpenEBS for which we started off testing. So we started chaos testing for the OpenEBS project as well previously, and then we moved on and developed it into a chaos engineering project for various workloads. There's Cassandra based experiments, core DNS based experiments. For AWS, you have a certain set of experiments, and plus further we are developing experiments for VMware, Azure, and various platforms. And these are basically the experiments. So you can see that there are various experiments like a pod delete experiment or a pod CPU hog experiment, or these are the various sections where you understand that how a chaos test is curated. And let's say what are the repercussions if a pod gets deleted, or what are the repercussions if you curate a chaos engineering experiment as a workflow. And these experiments, for example, you can as a workflow, you can curate the experiments in series or parallel. So this is how various chaos tests are curated, and these are the experiments. You can check out all the experiments in the hub, and in case you request an experiment or you want some experiment to be added, you can always share your request, and these experiments can be added to the hub. So perhaps I'll ask Amit to start talking about Litmus in a nutshell. This is the portal, as you can see, and then he can perhaps get started with the portal
Sure.
itself.
Thank you, Prithvi. So, so in this screen, like we can see that the Litmus portal, since it's a cross-cloud control plane, it can be installed on various agents. So, like we can see that the Litmus portal is present in the Kubernetes and then in virtual machines and the other public cloud services like AWS or GKE. So by default, we have some default resources like we install the chaos agents, chaos operators, which allows to add the CRDs, and we also add the chaos metrics and chaos events for the analytics. So, Ritik, can you take next? Yeah. So we actually support the Helm chart. We support the installation from Helm, and in the portal we have different hubs. Like we can connect our private hubs as well as public hub. By default, we also have the chaos hub that Prithvi just showed. Yeah, next. Yeah, so like we can curate our chaos experiments from the public hub as well as the private hubs. Yeah. So this also works on the cloud and on-prem setups, and it also works on VM and bare metal setups since it's a cross-cloud control plane, and it's on top. It's basically on top of Argo CD. Yeah. So like the Litmus Chaos workflow is actually based on the Argo workflow since it consists of different steps like from installation of the experiments to installation of the uh, chaos engines and everything are basically different steps that we follow during the chaos workflow. And we have recently supported the GitOps functionality from the portal as well. And we can also view the status and the results of our chaos experiment. We also get the probe success percentage and the resiliency score in the portal as well. Yeah, if you can go next. Okay, so like we have just Prithvi showed like the number of experiments we have in our chaos hubs. So these are few of the categories. Like we have the generic category, we have the open APS category. Similarly, Kafka, Cassandra, Cube AWS, and recently we have added the VM category as well. So these are some of the categories like the pod chaos, the node chaos, and the other infra level experiments. And we have also the cloud services experiment, like we can terminate the EC2 instances and other AWS related experiments. Okay, next. Okay, so we have also support for the analytics from the Prometheus and Grafana. I guess Ishan and Ritik will be showing it later today. And yeah.
Yeah, so as you can see that this is a Grafana dashboard, and here we are curating our chaos test. So the red zone or the red section is where you can see a chaos test is happening, or we are trying to see how chaos engineering works. And then we use probes. There are various probes that are used as Litmus Chaos probes, and these probes basically check various use cases or how it basically acts as a health check. And the probe has a starting point and an ending point where you can use various values which match your criteria, your use case, and that is how the probes help you understand they act as a custom check which can understand the success rate of a chaos engineering experiment, or how successful you have been to curate your chaos tests. And as you can see, they can be observed on Prometheus and Grafana. And further, we are planning to integrate with various tool sets out there: GitLab, GitHub Actions, Spinnaker, Captain. These are already being done, and they are part of the Chaos CI library, part of the CI/CD pipeline, and you can obviously deploy them and see. I mean, for example, Captain is a CNCF toolset again, and it helps you basically understand quality gates. It helps you understand your SLOs as well. So that is how we are planning to, curate with various tool sets out there. We have Flux and Open Telemetry and Iterate and these projects in pipeline where we want to integrate with. And as of project status, we can see this is the current traction. It's all about community, and these are our community members. And you can also join the community and be a part of it and contribute. You can raise issues, raise PRs, or ask us if our community can contribute anything according based upon your use case. And this is what we did at KubeCon. As I think you have already seen, most of you might have been part of KubeCon EU, and this was a basic overview of KubeCon. So I'll just let Amit share his screen, and I'll be forwarding the links. Perhaps I would urge you all to join the Slack community, the Litmus Slack community, where we talk everything about chaos engineering, take up queries and put out updates. So, and we also have our community calls where you can come up and give suggestions. So, and I think Sri Bala has asked for a reference between Litmus and Chaos toolsets. So perhaps I'll try to give the comparison in chat, or just send a few important aspects on chat itself. So Amit, you can start sharing your screen and take everyone through the portal itself.
Thank you, Prithvi. Probably share my screen. I hope my screen is visible.
Yes, Amit, your screen.
So, hi everyone, I'm Amit Kumar Das, and I'm working at Chaos Native, and I'm also a Litmus contributor. So, from 1.2 to 2.2, we basically have improved the UI and user experience of Litmus Portal. So, this is how the portal looks. So, this is the landing page where we can see all our previously scheduled workflows. We have a brief information on how many agents are connected and how many projects we are part of. And similarly, on the workflow side, we have also improved on the browse workflow table where we can see all our workflow details. So like if I click on one of the workflow, I can see we have an option for the graph view as well as the table view. So in the table view, you get the complete overview of the number of experiments and the steps that are present. Similarly, in the graph view, it actually gives a better picture of how the workflow has run. And we now can see the logs and the chaos results as well. And in the chaos result, we can see the processes percentage and the verdict and phase. Similarly, we can also download the logs and we can view it. So, so these are some of the features we have added in the browse workflows. And similarly, in the chaos hubs that Prithvi just showed, so we have one default hub present, which is pretty similar to the hub which is present. So this is the default hub which is present. And when I click on it, I get all the experiments which are present in the hub. Some of them are like the chaos charts, like it is a basic chaos engine that we can tune to schedule our experiments. And we also have the predefined workflows. So currently we have two predefined workflows, which actually injects chaos on real world applications. So we have the Sock Shop application and as well as the potato head application. So we inject chaos on these applications. Similarly, we have the agent screen where we can get a overview of where all our Litmus portal and Litmus agents are installed. And analytics sections, I guess Ishan will be giving a brief demo on the analytics section after this. And in the settings page, we have some major changes, like we have added the teaming section, and it's much more configurable now. We can edit the project name. We can add or create a new member. We can invite some new members. We can also assign the roles, like we can assign the role as editor, viewer, or owner. And we have the user management tab like earlier, and we have also introduced the GitOff functionality. So with this functionality, like we make the Git as a single source of truth. So we just need to provide our Git URL and the branch, and all our chaos experiments will be saved on Git and will be triggered from Git itself. And we have also added the image registry change. So by default, we use the Litmus Chaos image registry for our applications. But if we want to add some custom image, we can provide the image registry and the repository name. Similarly, we also support the private image registry. So we just add the image secret and the namespace. So these were some of the features that we have changed from 1.0 to 2.0. And now I'll just go ahead with the demo on scheduling a workflow and how we can select the target applications. So we have few steps in the workflow creation step. So first is the agent selection step. So here I have the self agent connected. So I'll just select this one and click next. And we have also introduced different ways to schedule chaos experiments. So like we have 4 options here. So like create a new workflow from the predefined workflow template. So I've just showed this in the hubs. Like we currently support 2 uh, predefined workflows, the sock shop and the potato head chaos. And we can also schedule our experiments from previously run workflows by saving it as a new template. And we can create chaos workflows with the use of MyHub. So currently I just have a single MyHub, which is the default hub. And we can also create workflow by importing a workflow manifest. So for the demo, I'll be just creating it from the MyHub. So I'll select the default MyHub which is present. Just click next. And this is the workflow setting where you can give the name to your workflow and a description. Go next. Yeah. So majority of the changes that we have added is actually in this tune workflow screen. And this screen actually is probably like the heart of the Litmus portal. Like we can schedule and we can tune our experiments here. Not just the experiment, we can edit the sequence of the overall workflow here. So let me add a few experiments. So in my hub that I've selected, the chaos hub, I have all the experiments. So for the demo, I'll use the pod delete, and I'll use maybe pod CPU hub. Yeah. So as we can see, like when I add an experiment, the graph is also shown here. It basically gives a brief idea on how the experiment will be scheduled. Like for now, it is in a serial way, and if I want to edit, I can edit. I can make it into a parallel experiment. So we can see that we have the experiments running in a parallel way. So like for the demo, I'll just use it instead. I'll just discard the changes for now. Yeah. So now I can probably show the tune functionality. So we have few steps over here. When I click on the experiment name, so I have the hub name, I have the experiment name, and I have the context which is required for the analytics. And now comes like most important part, which is the target application. So like now we can target the applications from the portal itself. So it actually supports like the namespace and the kind and the label which is present in that app kind. So like if I click on the app namespace, I have a list of namespace which are present in my Kubernetes cluster. So we can see we have the default namespace, we have the code node, cube node lease, cube public, and cube system, as well as the Litmus namespace. So let me just select the Litmus namespace, and I can see like I have different app kind. So if I click the deployment and click the app labels, so it will briefly give me the list of deployments which are present in the Litmus namespace. So we have all the labels that are present here. Similarly, if I want to inject chaos on a stateful set, so I can click here and it will give me the available labels which is present in the Litmus namespace, which is Mongo, since we are using Litmus with Mongo. Similarly, if I select deployment from any other namespace like kubepublic, I don't have any resource available in kubepublic. If I check kube system, I have the KTS cube DNS available, so I can inject my chaos over here. So for the demo, I'll just inject my chaos on the default namespace, and I'll use the label app Nginx. I have a deployment running of Nginx. So we have also added the job cleanup policy as retained so that we can review the logs. So I'll just click next. And we have also added the functionality to add portals, add probes from the portal itself. So I can click here, add a new probe, and we have different fields here. We can give a probe name, and we also support the different probe types which are present. So currently we have the 4 probes, the HTTP, CMD, KTS, and PROM. So this functionality is also generic. So like if I select the HTTP, we can see some different options here. Like we have the method, the get and post. criteria and response code. Similarly, if I change it to CMD command pro, so we have the different criteria and different values to be provided. If I change it to KTS, so we have different options available. So we can provide the GVR, the group version resource, the namespace, the label selector, and the field selector. And if I change to cron, then we have the different endpoint for Prometheus and the queries. So I'll not add any rows right now. I'll just finish and create next. So we and for the pod CPU hog, let me just target some other application. So I'll just go ahead and select the cube system, and I'll try to inject chaos on the cube DNS deployment. So I'll just click next and finish. So we can see that it has also updated in this workflow tables. So we have one pod delete experiment that will target the default namespace with app nginx label, and we have the second experiment, which is the pod CPU hog. This will target the kube system namespace with this particular label, the kube DNS label. So we have the reverse schedule enabled, which actually adds the revert chaos to remove any redundant experiment or resources which are present after the completion of an experiment. So I'll just click next. And we have also updated the look and feel of this reliability score page. So we can tune our workflow. We can just add the different weights here, which is required for the calculation of resiliency score. I'll just click next. And here we can schedule our workflow accordingly. Like if you want to have a cron workflow, we can select the recurring schedule. And if you want to schedule it just now, we can just select the schedule now option. And in this page, we can actually view we can actually finalize all our changes. So we can actually view the YAML manifest, the workflow manifest here. And we can also check all the workflow name and workflow description and all the weights that we have just provided. So I'll just click finish, and this should start my workflow. So we can see that the custom workflow has just started, and it will probably take some time to get completed. So with the schedule workflow option, we can actually tune our workflow and add different ropes, and we can like customize our workflow with our own preference. So like if I select some of the sock shop experiment, I can tune it according to my requirement. I hope this is not coming for some reason. Just select potato. Yeah. So like we can see, like this will actually work on the Litmus namespace, which has the potato head label. So let me select the Litmus, and we can see that the label is actually present, the potato head label. So, or we can select on the some other deployment which has the required label we want to target, and then we can schedule our workflow. Yeah. So, Prithvi, I think that's it from my side.
Thanks, Amit. Thanks a lot. I think that I hope that clears a lot of doubts within people on how the Litmus portal functions. And I think without wasting any time, I would like to move on to the next agenda item. But perhaps if there are any questions, I would urge everyone out here to post it in chat, or you can also unmute yourself, raise your hand, unmute yourself, and ask these questions. Do we have any questions? Okay, I see none. So perhaps I would like to invite Ishan and Amit to talk about how you can improve your chaos engineering analytics using the Litmus portal. That's over.
Hello, hello everyone. Is my screen up?
Yes, yes, yes.
Yeah. Yeah. Hearty greetings to one and all. I'm Ritik, contributor at Litmus. So the main objective of chaos engineering as a discipline is to build confidence in a system, and a confidence can only be built up only if we are able to test its capabilities specifically in undesirable circumstances, which for an IT application might come up due to latency, traffic errors, and other saturations as well. So as part of monitoring infrastructure, we have analytics section in Litmus, which provides you with an complete set of matrices and visualization, which is required for viewing a chaos injection event, and also the performance matrices of other resources that we have. So currently, if you see my screen, we have the first tab in analytics section, that is overview tab. Now, overview tab guides you through the whole user flow of the analytics section. We have workflow dashboard tabs, application dashboard, and data source tabs. So in overview tab, you get the overview of all the three tabs. So right now here you see the user flow as per the user flow. Right now you see that I do not have a data source configured. So it will first prompt me to add a data source. So let me go, and here you see, while adding a data source, we have the option of Prometheus. We want to cater to other data sources as well. So I'll select Prometheus right now, and I'll name this as a data source. So for the endpoint, you have to give a Prometheus endpoint for scraping the matrices. Yeah, for the authorization, right now we support no auth. Later on, others will be added. And when I save, it will try to check whether the data source is valid or not, and it will let you know. Once you have data source configured, it will let you know that your data source is up now, and now you need to configure a dashboard corresponding to the data source. So now I'll add a dashboard. So for dashboard, right now we support two dashboards, that is Kubernetes platform dashboard and SockShop application dashboard. So let me select Kubernetes dashboard, and let's name this as KRS dashboard. And we'll select a data source type that is going to be Prometheus, and we have the data source named as data source, and we have the self agent, and we can view that these are all the things are going to be shown as part of the dashboard panel, and that's going to be CPU usage metrics, memory usage metrics, disk usage, and network usage. Once we save it, it will prompt us that it has been configured. So right now you can see that it's showing me a table of data source and a table for the configured application dashboards. So let me see for the analytics. If we go, then it will load me a graph. So here we have options of selecting the refresh rate, different refresh rates. So one dashboard I had already checked, and it was the same KRS dashboard. So we have all the graphs, metrics, and all that. So here you see that these are the chaos injection events that have been scheduled through workflows and all. So these are the separate metrics which we are viewing. So if we go on other sections as well, okay, so it takes some time to load the metrics. If we go in the workflow section, we see that 3 of the workflows have been scheduled. So let's go for the SockShop application and view its analytics. So here you see that these are few stack bars, and what do these stack bars correspond to? Let's hover on one of them and see. So here you see that it shows me a resiliency score of 60% and a pass fail. It says that there were like 5 experiments, 5 tests, out of which 3 have passed and 2 have failed. So these all runs, these are being showed at various intervals. You can see the timestamp that this was scheduled at around 11:30 at night. And these are the workflows that have run in the morning around 9 to 10. So when you have multiple workflows throughout the month or throughout the year, you can see how your resiliency has improved over a course of time. And the best part comes when you are able to compare the workflows. So for comparing, let me select 3 workflows and let's compare them. So here you see we have a graph where you are able to see at 28th, we are getting a 60% resiliency score for this, 80% and 100% respectively. And over the course of time, we see that this has become 86. So this is the change which we have observed among these 3 or 4 of them. And later on, if we have multiple workflows, we will be able to analyze that also. So now for an SRE, a graph is good, but for any development process, we require some good report, right? So we have export report option, which by which we can download reports. So let me download this report and let's see. I have downloaded one in the morning, and let me check this one. So here you see we have a complete report of all the workflows that we have scheduled with the workflow name and where when these have been scheduled along with graphs. And here you can see what was the cluster name, how many experiments have passed, failed, the corresponding resiliency score, and for every test that have passed and failed, what is actually the status. So you have here you can see in the report generated like how you might able to require to tune your application that has been deployed to improve your resiliency score. So this is one of the features in analytics. And yeah, in like I had earlier scheduled a KTS dashboard, now you can see the same thing to appear in the application dashboard, and in the data source as well, it is coming up that this is active. Now let me try to delete a data source. Now remember that this particular dashboard, this KTS dashboard which we have created, is dependent on this data source, right? So if we go and delete this particular data source, then there should be some issue with that. So it clearly says that fail to delete the resource. Do you want to force delete? So if we go and force delete, it will allow us to delete the data source even if it was dependent. And it gives you a freedom of deleting data sources, and you see that the corresponding dashboard has been also removed because the data source was deleted. So these are the a few of the features which we have been working on. And now I would request Ishan to carry forward.
Yeah, sure. So I'll be sharing my screen. Okay, I hope my screen is visible.
Yes, Ishan.
Yes, Ishan.
Okay, so hello everyone. I'm Ishan Gupta, currently working at Chaos Native as a software engineer, and I'm a contributor to Litmus. And so basically, I focus mainly on monitoring and analytics aspect of it. But yeah, so today I will be showing you the features as Ritik has just showed just now. So we would be talking about mainly the analytics and monitoring section of Litmus. So as Ritik has already showed you the wizard for dashboard creation and data source creation, and similarly in workflow dashboard you had one more feature. So I would let me go full screen. Yeah, so you can so if you have a so one feature I would like to point out, it's if you have a workflow which is running for past some couple of days, so you can hover over it and see the things. And also you if you click on the bar, you will get to see the exact all the test names. So whatever the test was there and what have failed or passed, and what the weights of the test. And so this Amit was talking about when he assigned weights to each and individual test. So these are the resulting points of that. So this resulting point is calculated from your probe success percentage. So in an experiment, if you add a probe, it will be taking it will be factoring in the results of that. Like if you have a 2 or 3 probes, we take the average percentage out of it and then assign that probe success percentage for an experiment. And if you have no probe selected, we just take the experiment verdict as pass or fail as 0 or 100%. So those results are just for single experiment. But when you have coupled microservice or dependent service which you are testing in parallel with the as Amit was showing, if you have a schedule some experiments in parallel in a workflow, so you check your authentication system for an example, or and at the same time you are viewing some database scheduling some chaos on a database. So at that time you can correlate and both of them how they perform during that time. So you can assign the importance and weights in form of weights to them, and the final resilience score is the weighted average of the points you have assigned and the probes, the result of the probes which you have got. So so in this way we factor in the both user defined information and also the results coming from the experiment to fine tune the resilience score. And then you so yeah, so that was one thing. And other than that, I would also like to show both the portal analytics and the monitoring part of it. So let me just, yeah. So here we should okay, first let me talk about the updates we have made. So just for the info, we have a chaos exporter. So we have enhanced this chaos exporter. This is the deployment, or you can say the microservice responsible for like scraping the metrics from your cluster. And it generally scrapes the all the chaos metrics which are available and the event. So earlier we were using Heptio event router, but now we have shifted to using Chaos Exporter even for the events. So I will show how you can construct Grafana dashboard using those events and add the annotations in both Portal and Grafana. And similarly, so in Chaos Exporter we can see we have a, so this whenever you install or connect any agent from the portal, like you can connect agent from here, when you connect agent using the Litmus CTL, so it will directly install the agent to your connected cluster. When it installs the agent, this exporter comes in as a part of that installation bundle, and it will be installed for you by default. If you're using Litmus 1.1.0 and not using beta or 2.0, 2.0 beta version, so you can install it separately and use those these metrics to obtain good the Grafana dashboard and all. So this is primarily a Prometheus exporter, but it also has some you can export events for you to AWS and all. So this is so we have some metrics these are basically gauge metrics. It will be a variable with a count value. Like it can be I have some experiments running, so it is like you can see I am using those metrics as total experiment what I've run, and the past experiment among that, and the fail experiment among that in the last 1 hour. And so these are the metrics we will be utilizing in Grafana, and in Prometheus also you can view, or any other observability tool. So this is one thing. And yeah, we have Litmus Chaos. So we have added some of the new label filters called we are now we have the application details. As you can see, this chaos engine context which Amit was showing. So whatever chaos engine context is like a reference which you can use while seeing the effects of chaos on a dashboard. When you monitor your microservice, you can so these all whatever context you would have provided to the engine, you can directly correlate that test on a dashboard to how your on that is overlaid on. So these event metrics will be overlaid. So let me show the event metrics first. I guess this thing, if I could remove somehow. Yeah. So let me select some more maybe disk fill. So yeah, this one has happened. So here also I will be using this disk fill chaos. So as we can see, we have two metrics. So here, let us consider here. So we have had this disk fill experiment done on the catalog DB. So this is the your catalog DB is we are why it is. Okay, I guess this has something I should. Yeah. So this is we have scheduled like chaos and injected chaos on the catalog microservice or catalog database. So we were exporting metrics for that, and you can directly get to know what was your injection the target of that experiment. So as you can see, whenever we did this chaos, the latency of the catalog service went up, and similarly you can see a spike in the queries per second. So because of the disk was getting filled here, and it is a stateful set we injected chaos on. So it passed the experiment because we added no probes. If you have a Prometheus probe and something to check, if this goes above a certain value, you can make the experiment to fail, and you can factor that result in the report that Ritik was showing and all. So if you have no probes, we ideally check if the service is still alive. Like after that, it comes down to the normal state, and if the service is still alive, we make it pass by default. If you have a better if you have add probes to check better, like a K-test probe or command probe or Prometheus probe to query these metrics, and then tune your experiment result based on that. Like so, for this purpose, it has passed, and the probe success percentage you can see, and the catalog, what was the target of this chaos. And so this was one thing. Now coming off from the exporter, so these were some of the enhancements we have made in exporter. Now I will show you how we so in portal also, we when we construct a dashboard, so portal offers this inbuilt, like in Grafana, if you want to get this annotation, you have to add some annotations and then use some template variables to get to get the annotations and overlay them on top of your application metrics. But in portal, we support it by default. So whatever dashboard you create from here, or so soon we will be providing some more features to it, like if you can edit the queries and maybe create your own custom dashboard. So all those will be coming up with this event annotations inbuilt. So users can directly use these annotations on the metrics. So whatever metrics I was showing on Grafana is the same thing which we show in portal today also. So once you create a dashboard, you can see those metrics there too. And then let me come back to this Prometheus UI. So this was the verdict. This was the metric I was talking about. So this is kind of one of the most important metrics which we are exporting, called Litmus Chaos Awaited Experiment. This gives you the interval during which the chaos was active. So you can use it as a annotation, like a metric for annotating when this chaos has happened and what was its result. So Litmus supports this concept of like open observability. So what we do is so we don't so in portal also, you see, you get to add your own data source, and you can connect your dashboards and use. In Prometheus also, we add the scrape jobs to use, and these metrics which the exporter is exporting can be exported to other APM tools and all also, and it can be fetched directly. So this thing is what makes it more cloud native from a chaos engineering point of view. And then let me show you some updates regarding this. So I will watch the data for last 3 hours. That would give me more events. Yeah. So coming back to Grafana, as you can see, I will talk about what enhancements we have made on the SockShop dashboard. SockShop is like just a basic. We are giving an example as like how you can also get this chaos metrics and interleave them on top of your application metrics to get a clear picture of how your applications are performing under chaos or under stress. So some updates are like previously we had some fixed values of chaos results. You would have to add for each new engine you create. These results were not dynamics. Now we have added a way for the users to select if you want some more events from some more engines, if you select them. So as you can see, if you have parallel running experiments and all, you can deselect them and view only those events and metrics which you want to view. Like here, I guess I should also let me zoom in. Yeah, so here we will be able to see the effect of chaos better. And similarly, you can also select your engine context. So this will basically guide you to get the verdicts. Like these are two matrices actually. Like the first metric is this one is the Litmus Chaos Awaited Experiment. So this gives you the duration when the chaos happened. The final metric is like a configurable parameter. Like you can pass this environment variable to your chaos exporter, even edit it, or if you install the agent, it is the default scrape interval is 5 seconds. So it will keep exporting the final results of the experiment for 5 seconds, and you can so whatever is your Prometheus scrape interval or the time series database scrape interval, you can tune with that, and so it will export for 5 seconds and then stop exporting that result metric. So these are two metrics. If I disable one of them, like if I disable the event, I can see only the final verdict of the experiment. And if I want to just see currently look for the events, just the events that when the chaos happened, you can also view them. So these are some of the advanced features we have added in recent times. And then is this is a panel which will, so here you can select all the chaos experiments you want to view from the chaos result names. So chaos result name is basically, this is your engine name, and this is the generic experiment name which you can find on my hub, or chaos hub, or the public hub which is there. So and so these are all the experiment that has run in this time, and I have selected few of them to view. So whatever I would select, I can view on my application metrics and find out how they perform, if they're QPS or latency has spiked up and all. And similarly, we have added two more new features called, we have added Grafana alerts. So these alerts are, if I edit this, so these alerts we have added is it is taking in the chaos result verdict as fail. So as you can see, among the this will and one more thing to note is that we are not using only the selected metrics here. It will check for all the events or all the chaos engines that have been created on a cluster, and all the chaos that has been injected, and whichever of them has failed, it will be taking in for issuing Grafana alert. So this is how we give that query. We use a we have this chaos result verdict as a another label selector for this particular time series query, and this is the fail we are checking. So whenever an experiment fails, this value spikes up to 1, and we have configured it as a log. If just to give a overview of how you can also you can configure the same thing. So you can go into the display section, and you can use this access and legend values you can configure to log base 2. So it will either issue a 0 or 1 based on your result pass or fail. So whenever your experiment fails, it goes up to 1, and the alert section, you can add this alert. So this dashboards are all publicly available. I will show where in some moment. So you can check just if it is above 0.99. So Grafana issues the alert. So as you can see, this there's a red color heart and all. So this indicates your some of your experiment has failed and alerts has been issued. So this alert also in Grafana, you can use our to get proper relate better with the experiment that has happened, and what was its target, and what was the probe success percentage, and the chaos verdict and failure and all, or if it has passed. So this entire thing you can provide a template to Grafana. So this will be substituted dynamically depending on whichever experiment has failed. And this template is something which will be you will be getting mail or in Slack as notification or in pager duty. So whatever Grafana supports, wherever you can export these alerts to. So this Grafana has the alert pipeline, so you can configure the alert channels, and depending on the alert channel you have selected for this, it will be, so whenever your experiment fail, it will be exported to that. So earlier we did not have that we did not create that thing for the community earlier, but now we have added this both the use case as a sample use case, where you can maybe customize your own if you have already, or if you're using this feature already. And so this is just to show how you can use the chaos result verdict. Similarly for probes, as you can see here, you notice we have this probe success percentage was 0 for this chaos result name or this experiment on this was the target of it, name equals to catalog was your the label of it. So you can edit this. So app label, so you can we can again go to see this is the same kind of thing. We are issuing the same template, and the query here is different. So we are checking just probe success percentage is not 100. So you can check any you can give a different comparator, if it is less than 90% or 50% or any template variable you can use to failure alert and this. And similarly in notification channel, once you add a channel, so wherever Grafana supports all this like Discord, email, uh, all pager duty, as I said, and Prometheus alert manager, Telegram, Slack. So all the places you can whatever software you are using to log the events or get notifications, you can use them. So this was one thing about Grafana dashboards and how you can use them. So similarly, whatever I just showed is available publicly on Litmus monitoring, Grafana dashboard, and SockShop. So so this you can find everything I explained now as like different sections and how you can use these alerts and to get the proper metrics and notifications when your experiment fails or something happens on the cluster after scheduling that chaos. So this was in relation to the dashboards. Now some more updates which we had now, and so these are some minor updates that we did now in Grafana. So we had a, if you go to monitoring folder, there's a setup there's a wizard using which you can set up the entire monitoring stack I just showed. So this setup is so in this release, the past releases, we have added this scrape jobs for fetching this node exporter metrics and cube state metrics. Earlier it was that we had to use Prometheus operator model, and we had service monitors for node exporter and cube state metrics. Now we are having normal scrape jobs, and you can use the Prometheus deployment with some replicas and just fetch those metrics. And so this was another part which we updated. And there's one more updates, if you are using our Grafana our monitoring setup wizard, so here you get to install Grafana also. In this folder we have made some changes. Earlier it was that all the dashboards which you were getting, you had to go into this, so all are available in Litmus monitoring folder. And then the depending on application, we have Percona, dashboard for Percona also interleaved with Chaos. So these dashboards are different than the normal dashboard available on Grafana marketplace. Is that these dashboards are interleaved with Chaos events, as I just showed. All those alerts and all the things you will get configured. And so in monitoring setup, if you go to utils and Grafana, so we have added, as you can see, we have added config maps for data source and dashboard. That means when you install using our monitoring setup, you will get all the predefined dashboard. By predefined, I mean whatever dashboard Kubernetes dashboard, we have node and pod chaos metrics, and in SockShop. So this is taking node exporter and cube state metrics, and SockShop metrics you can get, and Percona. So these all you will find auto install with your Grafana, as these are provision dashboard and provision data sources. So that was one more update just for the community, so to get onboarded and to use Litmus monitoring setup. And yeah, so I guess that was it. Yeah, so I guess that was it from the monitoring updates. And so any questions on this? I'm still audible, right?
Yes, Ishan, you're audible.
Okay. So, let me check. I will stop sharing probably. So thank you all. If you have any questions, you can drop on the chat window. I will answer them.
Thanks, Ishan. Thanks a lot for those updates. So we'll be moving on to the last section of the meetup today. And I would like to invite Udit Gaurav to talk about the DNS chaos engineering experiment and perhaps put out a demo. And before that, I would just like to reiterate again that I'm forwarding the GitHub repo link. There are a lot of new folks joining in, and perhaps they can start by checking the GitHub, the LitmusChaos GitHub, to get initial resources. And I would urge all of you to join the Slack community. So I'll also be forwarding the steps to join the Slack community. So perhaps you can just check them out on chat right now and join the Slack before the meetup gets over. And I would like to invite Udit now. Udit, you can start sharing your screen. Udit, are you there?
I think Udit is having some network issue problem. I can show the demo if that is fine.
Sure. Mo, you can go ahead.
Okay, let me share my screen. So, is my screen visible?
Yes, sure.
Okay, so basically, this demo is for the DNS chaos experiment. So a brief introduction to the DNS chaos and what it targets and how it can be useful. So in a cluster, right, we have multiple microservices communicating with each other, right? And usually we have a service name allocated to each of these services, right? And the service name is what the microservices use to connect with the other services. We do not usually use the service like IP addresses or service IPs for this kind of communication. So in a cluster, specifically Kubernetes cluster, we have the core DNS or the kube DNS server running, which basically handles this mapping of the host name or the service name to the particular service IP. This is also for the private host names like private services, and also for the external communication, like if your microservice or if your service is communicating with an external API or something, the DNS resolution will also happen through the core DNS or the kube DNS server that is running in your cluster. So there might be situations where the DNS server that is running in your cluster gets crashed or corrupts, right? So in such a scenario, the whole cluster basically loses its capability to resolve the DNS name. So there's a network-wide, like cluster-wide communication failure. So any microservice, any service that depends on this DNS resolution will eventually fail, and that is what this experiment targets to simulate, so that you can test how well your application can handle such scenarios and how well it can recover if possible. So for this setup, like to run the experiment, I have set up in my local system. So I'll just talk about that first. So I've already installed Litmus Portal and the agent and everything, like we have seen in the previous demos. And with that, I've also installed an application called Potato Head. So this application is a CNCF maintained demo application kind of, which can be used for different, either for learning DevOps or doing some specific demos, right? Like we are doing in this case. So this version of Potato Head is a little different from the one that is officially there in the actual repository. Like there's a new branch called microservices in that CNCF repo, which is hosting this version of the Potato Head. So in this version, we have, as you can see, different services running for each part of the Potato Head application. So I'll just show you how it looks. So this is the main Potato Head application. That is how the front end looks for that. And here we can see that this image, right, is actually made of different parts. So each part is actually coming from a different service altogether. And there's a main service, which is, collecting all these parts from the different services and showing it to you. So this is what the version I'm using. And I have deployed two versions of Potato Head. So in this one, you can see that this is the version 0.1.0, which is basically this image that you can see. But there's also a different version, like there are multiple versions of the Potato Head. So this version is 0.1.3, which shows this kind of image. So I have deployed these two versions of the Potato Head microservice in two different namespaces. So this is the application. This is one of the 0.1.10, I guess. Yeah, this is 0.1.0, which is running in the demo space. Whereas I also have another one, which is in the spoof. So this is running in the spoof one, which is the 0.1.3. So this is the setup that I'll be using for the DNS chaos experiment. So I already have the experiment manifest ready with me. So I'll just go ahead and upload the existing manifest itself. So if I can quickly, So I've uploaded the manifest and I'll pass the steps. So here we can see if I zoom in. So we have the install chaos experiment step, which will install the DNS chaos manifests and CRs basically. Then we have at the pod DNS error chaos. So this chaos is basically going to inject a complete DNS fault in the application. So the application will lose its ability to resolve particular DNS names basically. So any host name or any domain name that has particular keywords will be like there will be a failure to resolve those particular domains to the IP addresses. So that is what DNS error does. So we can also do it at a like for all domain names, like we can cause the failure for all domain names that are being resolved. That is also possible, but this one is configured to do it on specific domain names only, or host names or service names basically. Then we have a recover step, which is basically a sleep in between so that the application can recover. And then finally we have the DNS spoof experiment, which is basically going to spoof the DNS request. So for example, if my application is trying to look for google.com, so let's say my application is trying to connect with google.com, but what DNS spoof will do is basically it will spoof that particular address that corresponds to google.com to some other domain name altogether. So this kind of scenario happens when let's say you have an older cache, DNS cache in your server. So the service IP has actually updated, but your DNS server has not updated the record, or it might be happening due to deliberate DNS cache poisoning attacks also. So this is how we are simulating these two errors. So I'll go through the setup also, like I'll talk a little about the settings that I have here. So for the DNS error experiment, what I've done, this is a chaos engine for the DNS error experiment. And here you can see that I have set the target host names to ARM. So this has a match scheme of substring. So basically any domain name or any host name or any service name that has the keyword ARM in it will be will be blocked by the experiment. So the DNS resolution will fail for those domains. If I left it empty, then any domain that was being resolved would fail. So in this case, it will just be for the arms, anything that has the ARM keyword in it. And for the spoof one, what I'm doing is basically I'm spoofing the pointer head left ARM, which is running in the demo space. So this particular microservice. So the microservice that is corresponding to this ARM with the pointer head left ARM in the spoof domains, spoof namespace. So basically, the goal would be to change, like to spoof this particular service with the service that is running in the demo space, the spoof namespace, sorry. So that is what this particular workflow will be doing. So I'll just go ahead and save and run the experiment. So I'll schedule it now and I'll finish it. So the workflow has started and we can see the experiment started. So, yeah, so this is the experiment starting off right now. So now we'll have the install step first, and then we'll have the error experiment. So we'll have to wait for a few seconds for the install to be completed. It's taking some time due to my network issue. Yeah, it has completed. So the error experiment has DNS error experiment is going to start now. So the workflow is being initialized and we have our runner. Yeah, so the runner has come up, and once the runner comes up, we have the helper also coming up, which is when the actual experiment starts. So the helper is also up. So if we go back now and try to refresh the page. So yeah, so I refresh the page and we can see that the arms are missing. The arms were not resolved. So the main server could not get the data or the image for the arms. So this is particularly missing right now. And once the experiment is completed, which will take around 60 seconds, we should be able to refresh this and the arms will come back up again. So this kind of scenario, like I said, is possible when either your DNS server has crashed or there is some other problem with the DNS server itself. And as you can see, like this can cause big issues, like pretty big issues in your actual microservice system itself, while your microservices are unable to communicate with the other microservices. So there are other ways of being able to simulate this kind of scenario, like network corruption, network latency, or some other thing that basically disrupts the network connectivity altogether. But this is specifically targeted for DNS situations, DNS resolution errors only. So the experiment has completed. So if I refresh, yeah, so the hands have come back. So the DNS experiment has completed now, and we are back to the normal state. So once this experiment finishes, we'll wait for around 30 seconds again, and then move to the spoof one, which is basically where, as I said, we'll be spoofing a particular service to another service. So this not only can be used to simulate a chaos situation, but also it can be used to basically create a mock service that you want to communicate to, and you can inject your this chaos and see what happens if the particular service that you are trying to access gets the wrong data from the other dependent services. So that is also possible with a spoof experiment. So I think the sleep is running now. Also, we can see the logs for the experiment, chaos result itself. So we can see the chaos result has passed because the pod is healthy and everything is going good. So the spoof experiment has also started. So the spoof runner has started, and once the helper comes up, we should be able to see the change in the application itself. So the helper is up now. So if I go back, so now we can see that the complete pointer head is on version 0.1.2. So the hands and everything are on that particular version itself. But if I refresh now, the particular microservice that retrieved the hand of left hand specifically has been changed with the version running in the spoof namespace because of the spoof experiment. So we can spoof any of the body parts or any microservice basically, and we can do the same experiment over and over. So that was all for the demo for DNS chaos. Prithvi, you can take over.
Thanks, Shomo. Thanks for taking it up last minute and for that amazing demo. So I think with this, we are coming to an end to all the items that we had. And perhaps I'll just open the floor for any questions or any introductions or anything anyone wants to talk about for the next couple of minutes, and then we can wrap up. Do we have any questions or any suggestions or anything? All right, folks, I think with this, that was it from our end. And I see a lot of new folks joining in. I will be sharing the recording on the LitmusChaos YouTube channel. I think one of them has asked, so I'll just post the link to the channel, and folks, you can subscribe to the channel. So the link will be posted by end of day today or tomorrow itself, tomorrow early. So we'll post the recording there. So folks, you can subscribe to the channel and get that. Anything else? Anyone, any other questions, or anyone wants to introduce themselves and talk about their chaos engineering needs or anything about the community itself? Thanks a lot, Piotr, for those reviews. All right, folks, I think that was it from our end, and I would be looking forward to have you all on Slack. So feel free to join us on Slack, and let's keep connecting and see you next time. We always have our Kubernetes Chaos Engineering meetups on the 4th Friday of the month. So let's see you all on the 4th Friday next month. Thanks, everyone. See you. Bye-bye.